Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own Mascoda this side. So in today's question we are going to discuss the problem vertical sum. So the problem states that you have been given a binary tree. You have been provided with a binary tree, right? And now in this binary tree you have to draw out your levels in a vertical fashion. Levels like vertical levels, right? Vertical levels. That is, if I say this is one of my level, right? Both 5 and 6 are on this level, right? Both 5 and 6 are on this level. Okay, another level is this, which is going through 2 and 8. Another level is this, which is going through 4. Another one is 3. Another one is 7, right? So I can say this is one of my level, this is another, this is another, this is another, this is another. That is total I have 1 2 3 4 5 levels, right? I have 5 levels. Now, the question requires me to give the answer in such format that I have this as first level, second level, third level, fourth level, fifth level. So if I list out the elements, so my first level actually contains 4, second level contains 2 and 8, third level contains 1, 5, 6, fourth level contains 3, and fifth level contains 7. I know that some of you might be considering that why is 5 and 6 on the same level. So if you can see, if I'm standing at 0, I go towards left, I come towards right. So 1 and 5 are on the same level. Similarly, for 6, I go towards right one step, I come towards left one step. That is right and left cancels out, and 6 is on the same level as 1. So actually 1, 5 and 6 are actually on the same level. Now, if I try to find out the sum, that is the first level has a sum of 4. Second has 2 plus 8, that gives me 10. Third has 1 plus 5 plus 6, that is 12. Fourth has 3, and last one has 7. So the question requires me to give the output as 4, 10, 12, 3, 7. This will be my final output. So I hope you are able to configure what is your input and what is your output. That is not a problem to you, right? Okay. Now you are here to see the approach, I guess. So let us move to the approach. So in this question, I was able to figure out the easiest and the foremost approach that we can use. What is that approach? So while discussing about the binary trees, the only thing I know about binary tree is traversal. I have always solved every question while using the traversal. It can be pre-order, it can be post-order, or it can be in order, right? Okay. So in this question, I would like to use pre-order, but please feel free to use post-order and in order after getting the grasp of the topic of the approach using pre-order, because post-order and in order are also, you can use them also, right? So I will say that this was my level 1, this was my level 2, these 3 were my level 3, this was my level 4, this was my level 5. Can I renumber them? Can I renumber them? How? I say that I don't know anything else. I just want my level of the root element as 0. Okay, assign it as 0. If this is my 0, that is I have to subtract minus 3. That is 2 becomes minus 1, this becomes minus 2, this becomes 1, and this becomes 2. Are you able to connect what I'm able to do? What I'm trying to do? I say I will do the simple traversal. I will do the simple traversal. Right? Now, let us consider pre-order traversal. The pre-order traversal works on the basis of, first I will do the calculation for my root. That is, I will explore the values of the root. Then I will explore the left subtree. Then I will explore the right subtree. Okay, I take that as an example, right? I say in the pre-order traversal, you actually send your node, right? In the pre-order traversal, you actually send your root. I say send one more parameter. Send one more parameter. What is the parameter? That will be your level number. In this case, minus 2, minus 1, 0, 1, 2. Now, because while starting the pre-order traversal, you actually send the level of the root, right? So what is the level of the root? It is 0. I say it is 0, right? Called for pre-order root 0. Now, how will the pre-order get defined? So that is me defining the pre-order, which will take my node and my level. Okay, so I have got my node, I have got my level. Now when will pre-order work? My pre-order will only work if my node is not equals to null. Then only my pre-order work, right? In that case, my first operation is explore root. Explore root. Now I don't care what elements are there in the level 3, what elements are there in the level minus 1, what elements are there in the level minus 2. I just care about their sum, right? I want, what is my need? I want sum. How? level wise, level wise. So what will I say? I will say take a help of a map. Take a help of a map. How? I will say just mine like I have got the levels as -2, -1, 0, 1, 2. -2 will store the sum corresponding to -2. -1 will store the sum corresponding to -1. 0 will store something, 1 will store something, 2 will store something, right? Okay. Now I am present at this node and this node has this level. Are you able to understand what I'm trying to draw out here? I am saying that if this node is not null, I will say, let us name it as my map as MP. I will say map of level. What will I increment in it? Plus equals to nodes data. Nodes data. This is the only operation I have to do, and these values get calculated. These values will get calculated, right? And after that, I will just do the simple pre-order traversal, that is pre-order of node left. Now when I'm going towards left, when I'm standing at 0 and going towards this left, you can actually see the level 0 is actually getting decremented. So I will send with node left, I will send level -1. Similarly for right, I will send pre-order nodes right level +1, level +1. So let me dry run it for you. How will my code work? I have called the node 1 with level 0, right? Okay. So it will do level 1, level 0 will get incremented by 1. It was 0 first, it will get incremented by 1. Then it will call for 2 with -1 and it will call for 3 with 1, right? Okay, 2 with -1, incremented. So -1 gets a 2, -1 gets a 2. Similarly, I will call for 4 with -2 and 5 with -1 plus 1, that is 0. For 4 with -2 will get a 4, right? And 4 with -2 will actually call towards the left, but that is not present, so I am skipping the null value. It will only call for 8, that is 8 of -2 plus 1 will give me, because 8 is present on 4's right, so -2 plus 1 give me -1. So increment 8 in the -1 condition, so 2 plus 8 gives me 10. All right, I got it for -2. Now this call is getting finished, this call is getting finished. Talking about this call 5 comma 0, I have nothing on the left or on the right, so this call is also getting finished after incrementing 0, after incrementing 5 at 0's position, right? Okay. Now talking about 2 comma -1, already done, both the calls done. In go to the top board, go to the parent, right? Now parent explores 3 comma 1, 3 comma 1. So while 3 comma 1, I will say 1 gets my 3, no problem in that. 1 gets my 3. Now 3 comma 1 will actually call 6 with 1 minus 1, that is 0, and 7 with 1 plus 1, that is 2. So 0 will get a 6 and this call will get finished. 2 will get a 7, 2 will get a 7, and this call will get finished, this call will get finished, and I will return to the driver function. Now my map contains 0 with 12, -1 with 10, 4, -2 with 4, 1 with 3, and 2 with 7. Now because I'm using a simple map, not an unordered map, I will get them in the sorted order. I will get them in the sorted order. That is, my map would look something like -2 connected to 4, -1 connected to 10, 0 connected to 12, 1 connected to 3, 2 connected to 7, right? I can just jot them down in my answer array. That is, I will create an answer array and I will push all these second value. That is, my answer value would look something like 4, 10, 12, 3, 7, and that is what we wanted as my output. So that is actually correct. Okay, that is actually correct, and yet here we are to solve the problem. We have solved the problem correctly. What is the time complexity? So you can see we just did a pre-order, so O of n for the time complexity. What about the space complexity? O of n for the recursion stack space, I guess, and O of n for the maps. Okay, so it is actually O of n, no problem. O of n time complexity, O of n space complexity, right? Nothing matters, right? Okay, let us try to move to the coding area now. All right guys, so here we are, and I would like to request you to please subscribe to my channel if you're new here, and if you're liking the video, do not forget to hit the like button as much as possible, right? Let us move to the code. So I will declare my map here only, map of int. Instead of sending it by reference again and again, I will declare it globally. Now void of pre-order, it was taking my node and it was taking my level. right? If my node is not equals to null, only then the operations will work. What was happening? I was saying MP of level plus equals to node of data, and then call the pre-order for nodes left, and while going left I will decrement my level minus 1, and same for pre-order of nodes right, and while going right I will increment my level plus 1, and I will say return, right? I will say return. Now here I don't have to do anything. I will just say that pre-order of root node, and what did I assign to the root node? 0, right? And now I will say vector of int answer for auto it in MP. What do? I say answer dot push back it dot second. This will jot down all the values of the calculated values in the map into my answer array, and I will say return answer, right? Let us try to compile and run it. Hope it will work fine, and hope you have understood the concept of the algorithm, right? Working fine for the sample test case. Let's try it out for the submit as well. In the meantime, this is my humble request to you. Please stay subscribed to me. Please stay tuned with me. Okay. So 142 day streak. Thank you for watching. Have a nice day. We'll meet tomorrow in the new video, right? Okay. Bye bye.